In this video, we'll talk about the naive Bayes algorithm. Okay, so and also we'll say why it's called naive. Okay, so that is very important. But we want to tell that this is an algorithm which is there for based on a formula which is there for a very long time, which is called the Bayes' theorem, which is about conditional probability. So this is an old concept, but this is still very useful, even though there are so many good, important sophisticated machine learning algorithms designed in recent times. So this is still simple, fast, accurate, and reliable. Okay, so as I said, this is the probabilistic algorithm based on the Bayes' theorem of conditional probability, which was published by Thomas Bayes posthumously in 1763. He was a British mathematician, statistician, and he worked on this formula, which says that probability of A given B is equal to probability of B given A times probability of A divided by probability of B. So here probability of A given B means probability of an event A occurring given the fact or a knowledge or an evidence or an assurance that B has already occurred. Okay, this is also called posterior probability. But to find this, we have to know that probability of B given A and probability of A itself, that means occurrence of event A, and then we divide it by probability of B. So here you see the basic assumptions are that features are independent. Okay, features are independent. That means, let's say, because or not because that it's a sunny day and there are some players playing outside, and the sunny day is the feature and the players playing outside is maybe a, let's say, class playing outside yes, playing outside no. And if it's sunny day and there are temperature is too hot, then there are two features. Then based on that, what will be the outcome? So these features are independent of each other, we assume, okay, for Bayesian Bayes' theorem. But it's not always true. Okay, it may not be true, because these features most of the time they are probably dependent on each other. Because it's sunny day, maybe the temperatures are high, or maybe because it's winter time, there is snowing, things like that can happen. So the basic assumptions, although, is features are independent of each other. So it's so naive that it makes that assumption. That's why it's called a naive Bayes. Okay, and also it's said that features are equally important. So every feature is equally important, and everyone has a contribution in deciding the posterior probability. And we will see some examples of this problem.